Why project-based learning? It's effective in all the ways that it needs to be. So maybe you're asking then, what are the qualities of an effective PBL course? Essentially, if you ask better questions, you get more substantial answers from your students. There's several different ways in which we can talk about how to set up and format a project-based learning course. I'm going to talk about the philosophies and learning sciences behind them so that you can actually see why they're important, why they're effective. We're looking at the Kolb model here. Research, and the Kolb model here is obviously showing you how you can have active experimentation and concrete experience and reflective observation and abstract conceptualization, all moving around and around. When you get that, students either learn by feeling and doing, or feeling and watching, or thinking and watching, or thinking and doing. Now, ideally, you can set up different activities in your course that will allow them to have all 4 types of learning activities. In having all 4 types of learning activities, going from feeling and watching to thinking and doing, around and around, research has shown that there's an effectiveness to this approach. Students are more engaged, skill development improves, their communication level improves, and their content retention improves as well. Now, this is all that we really want, right? We want this to be students to be engaged with high-level skill development and good levels of communication and to be able to retain their work. Think about how you deliver the work. I mentioned the Bloom taxonomy earlier. I think it's important to be able to look at this graphic and to understand a little bit more about what it's asking here. It's talking about the base level of knowledge all the way to what we're hoping is the higher order of thinking. Consider this. We live in a world of interconnected problems. Making sense of these problems and then acting upon them usually happens within the context of some sort of project. Particularly when we have to put together or assemble or create or formulate complex ideas and systems to help address these problems. A group of cognitive psychologists and curriculum theorists and instructional researchers and testing and assessment specialists published in 2001 a revision of Bloom's original taxonomy, and that's what you're looking at here. In this, you can see that the base level of this, remembering, can the student recall or remember the information? Gets advanced then if they can explain them. Or can they use that? Can they, in other words, apply that in a new way? Can they analyze it? Meaning, can they distinguish the difference between different parts of that knowledge? Evaluating it? Can they justify and stand on the decision that they make? And then can they create a new product or new point of view with that? So we start with the basic understanding and remembering of it. Then we ask to apply and analyze, evaluate and create. These are activities. We can't just expect creating, evaluating, and analyzing to happen unless we can first make a course format that encourages these activities to occur. I want to talk about a couple other philosophical roots in learning sciences of project-based learning. One is called active construction. So deep understanding occurs when the learner actively constructs meaning based on their experience and interaction with the world, versus what might be called superficial learning when information is passively transmitted. So in project-based learning, students actively construct their knowledge by participating in real-world activities, similar to that experts engage in. They do this to solve problems and develop artifacts. Think about how you can set up a course or set up an activity within the course so they can construct this knowledge. Think about what real-world activities happen so they can see themselves doing what others do. Situated learning. The most effective learning happens when learning is situated in authentic, real-world contexts. Students see the value and meaning of the tasks and activities they perform to themselves and their communities. They see then that the knowledge and the skills that they gain matter. They're able to situate who they are as people, as learners, within the importance of what's being taught. Information then in a meaningful context can be put in relationship to prior knowledge and experiences. When you do that, they're able to form connections between the new information that you can present and the prior knowledge that they have. They're not an empty vessel waiting for you to fill them up with all the knowledge that they have. You're asking them to participate in this, to contextualize, to situate the learning. Other examples, social interaction. The best learning oftentimes results from social interaction when the teachers, students, and community members work together in a situated activity to construct shared understanding. Teamwork and collaboration is an essential part of project-based learning. You can see here with this social interaction the intention of using teachers and students working collaboratively together and the inclusion of community members here. The inclusion of community members is also part of the situated learning. This can be part of a service learning course or any other courses in which you can help students to establish the understanding that the principles and ideas that they're using can be put in front of others, can be presented with others, can be debated. This back and forth sharing and using of ideas helps create a community of learners, helps to engage them in the community, and again to understand that what they're learning has application beyond just school. There's also cognitive tools and metacognition. I think this is an underused portion of project-based learning, but it's in fact quite effective when you do this. In this, you involve students in the tools and practices to encourage them to learn how to learn. Particular tools can amplify how they do this. Oftentimes I work with ways of enhancing their visualization. How do we show data or physical properties, etc., in ways that are maybe new or different or non-traditional ways? So these can range from either haptic or computer simulations based on the scenario. And you say to them, perhaps you ask them, what tool do you think would better help you visualize this? When you do that, you incorporate a range of new tools into the learning process. In fact, you ask them to incorporate a new range of tools. You expand the opportunities to learn in new and different ways. You couple this with the traditional plus delta or formative assessments in which you're asking students, what helped you learn? What did you do that you think was the most complicated part to learn about that? What do you think would be a difference maker going forward? Students then can learn which processes benefit their learning and share that information with you. As we've gone through some of the philosophies of it and the learning sciences behind it, what actually is project-based learning? How would we define project-based learning so that we can start putting together a format for what the course actually is? We all know that an effective way of learning is not to have someone put up a slide and read the words that are on the slide. What I'm going to do is just let you take a look at this and read this. And then in a minute, we're going to break down some of these words and see if we can understand and bring some more insight into what these words actually might imply for project-based learning. Every single one of these highlighted words is loaded with meaning. So high-impact practices are amplified educational experiences designed to increase rates of student activity while improving retention. The higher order skills, or the Bloom taxonomy that we talked about, and even the Kolb. What about meaningful collaborations? We could talk about what meaningful education is, of course. Collaboration is one of the 21st century key skills, the sort of soft skills here. We've talked about the situated inquiry-based learning. And I think this is an important way of thinking about it. So this is the sort of constructivist view of education, in which learners are expected to take an active role in the learning process by making sense of ideas and information they encounter. And so that's one of the Dewey and Piaget theories. So what you see is students were in there investigating the real world, authentic problems. Well, what's real? What's authentic? The active learning methods, the ways in which we're not just a passive learner, but we're, again, collaborative and hands-on. And interdisciplinary. Is it interdisciplinary? Is it transdisciplinary? A project-based classroom, where's a classroom? What classroom setting? And what's the role of investigating? I'm not going to go through all of these with you, but I want you, when you have some time, to think about when you set up your own project-based learning course, that within all of these sort of highlighted things are choices that you'll need to make. Choices about what's the classroom setting, what type of investigation, what type of ideas will be challenged, what type of proposals will be put together, what's public presentation mean, how will it be defended. In doing that, if you're really able to go through these things and make some sort of statement in your mind and as you plan it, I think what you'll find is that you've made your own rich project-based learning course format. As you're planning your project-based learning course, this is a lot of stuff to consider. And sometimes you're just kind of wondering, is there a way to do it? Is there an easy framework? Are there guidelines? These things that we've mentioned before take a lot of contemplation and a lot of work. It's best if they fit within an overall framework for your overall course planning. So let's start there. You may be asking yourself, how do I teach a project-based learning course? And so as it says here, I do wish there was an easy answer, but that's kind of the point of project-based learning. See, there isn't one approach. Just like there were many definitions to the terms we had mentioned in the previous slide, there's lots of different ways in which you could teach project-based learning based on the discipline, based on the objectives, based on the activities that you have in mind. You'll have to then change some of the qualities of the course, including the tactics that you have, the interactions with the students based on the rest of the setup that you have. These are things that we'll be doing in the next couple lectures to talk more about the in-depth tactics that you can use. But before you start teaching project-based learning, I want you to ask yourself this. Are you comfortable with the fact that there's no one right way to do this? That maybe there's same class could be taught many different ways and have lots of different results? If not, you need to start getting comfortable with it. Because the only thing given about project-based learning is this. You won't have total control over the class. It won't follow your plan. You'll need to do adjustments, and you won't be the one in charge of imparting knowledge. Students will be intentionally, because it's inquiry-based, charting their own path with your guidance, discovering things, creating things, evaluating what they've done. So you need to make sure that you're still okay with this idea because it's quite different than a teacher-centric approach. So a few resources here which I've found to be terrific in helping me to put together guidelines for what a good project-based learning course is. The first one here is the PBL Works, which used to be called the Buck Institute for Education. And PBL Works is in general about K through 12 education, but a lot of their framework, of course, is universal for any type of education. So what they have is what they call the gold standard PBL. In the gold standard PBL, and this is commonly interpreted by lots of other people with slight changes to it, but they want to start with the learning goals, which you can see in the very center. The center of everything is the learning goals, the purpose of the whole course. Around those learning goals, they have 7 essential project elements. This is your course design to make sure that you set up a framework in which these elements can take place. I'm going to briefly touch on just a few of these. The idea of a challenging problem or a question. It leads everything off. A sustained inquiry. This means your question is not a yes or no answer. It's not something you can look up on Wikipedia. Authenticity. As we saw earlier in the slides, the authenticity of the problem is what really creates the learning, embeds the learning in them because it situates their experiences, their involvement in their community. Student voice and choice. Anytime you can give them a chance to have a voice in what they do, a choice in how they direct their learning, it really helps. Reflection. Reflection is another way of talking about an assessment, a formative assessment time. You can reflect on their work, they can reflect on their work, meaning that there has to be these moments of evaluation as you go forward. Critique and revision. Critique and revision, as we're coming around the circle here, is another thing that happens at a deadline. This is usually when you're advancing from, say, a discovery or research into ideation, moving into testing. Each time that you have deadlines, you'll be able to have this critique and revision. And at each one of these deadlines, One of the key components is the public product. This is a presentation, or this is a production of some sort of artifact. So that's the 7 essential design elements. They then have the 7 teaching tactics there. I'd recommend that we're going to talk about tactics in a lot more depth in the upcoming lectures. Another framework which I appreciate is the framework for high quality project-based learning, or the HQ PBL. In this, it's going to look pretty similar to you. Intellectual challenge and accomplishment. Again, saying that it has to be challenging. I'm going to go down below here and talk about authenticity. Again, by framing the problem in an authentic situation. And because it's intellectually challenging, those two things work great together. Public product. Again, this is an important part of how you have these deadlines, how they can present their work, the artifacts that they build and create. Collaboration. Collaboration is a really important part of the soft skills that are embedded within a PBL framework. Collaboration both with their teammates, other teams, communities that they involve in their work. Upper corner, project management. Project management is just simply a way that if it's an inquiry-based, somewhat open-ended type of a course, can they manage their time? Can they manage this process of research and ideation and presentation? And back to reflection. This helps tie the learning back to what it is that they've actually accomplished and making sure that they can reflect back on what works that they did, things that were effective or things that were not effective. A third resource of just a terrific amount of experience and also scholarly research as well is the Worcester Polytechnic Institute, or WPI. And so they have a Center for Project-Based Learning there. The fascinating part about WPI is that they have had their entire curriculum, college-wide, be project-based. It's a really interesting story. You can read about this in the project-based learning in the first year book by Kristen Wabi that you'll receive as part of this. Nearly 50 years they've had experience in project-based learning. They've had these things in most of their science courses. They have a capstone project. A few resources here which I wanted to draw your attention to because they're really interesting and great sources. The first one is the Great Problem Seminar. Great Problem Seminar is an interdisciplinary course in which first-year students who aren't even declared in a major yet, collaborate with other first-year students in other disciplines to work on a topic of general sort of great problems: food, energy, water. And they create a research project and a proposal. Then you can also see that they've got, WPI has a PBL Educators Resource. In this Educators Resource here, you can see a lot of scholarly work and essays, even examples of the work that they've done at WPI. And WPI also has a really nice webinar series, and I've always really enjoyed that. It's a good way of learning some tactics or just generally being able to frame the work that you're trying to do within this larger context. Here at Iowa State, this Innovation by Design workshop program through our Center for Excellence in Learning and Teaching, we're looking at ways to try to take project-based learning and incorporate it with a mindset of innovation, way of thinking about design thinking. Design thinking is a more sort of updated version that's used in a lot of progressive companies. Whenever innovation and entrepreneurialism mix, trying to teach these skills to students in a wide variety of disciplines. So you can see here some of the phases of design thinking activities. It's what we've talked about before: discovery, ideation, experimentation, and evolution. And the design thinking process here allows you to actually go through very particular tactics. Now, it may seem like it's design-oriented, but it's like any other project-based learning in which it's inquiry-oriented, not design-oriented. It's certainly a valid way of doing it for all things, whether they're STEM or liberal arts or humanities programs. And so I tend to have these that I generally talk about as the main qualities of project-based learning courses. And again, you're going to see that these were a lot of things that were in the PBL works or in the high quality. What I would point out to you also is that we have some resources on our website at CELT all these different types of learning tactics. I'm a huge believer that even though you might set up a course with particular framework, if you're not aware of the different tactics you can use to be able to get, well, either responses to students or to have them engaged in the course, then the PBL thing may not work as well as you may want it to. This is part of the flexibility of how you teach a PBL course, is that you have to be able to change your teaching tactics. Because remember, it's not teacher-driven, it's not teacher-led. You're not the one generating all the knowledge, and they're not just the sponges of the knowledge. What you have to do is have tactics that allow you to be involved, but still put the work back to them. In that you can see that's under broad headings of active learning and haptic engagement. And we'll go through the rest of these as well as we break themselves down in the next upcoming lectures. We'll actually have like workshops where we'll go through some of these particular tactics. As I had mentioned earlier, in this particular lecture, we've talked about backwards design, inductive learning, case study method, coached ideation, even guided discovery. So we've done a lot of these already, even in this lecture. So how do you get started? Pick an engaging topic. Envision, as we did earlier in this lecture, the end. What does it look like? What could it look like when you're done? This is the backwards design process. Then you create what's called driving questions for your work. If you want it to be sustained work, we'll talk about driving questions in just a moment. Be flexible. Align and adjust your content. And finally, nurture the collaborative learning process. Practice the good tactics. Teach your students to trust this creative process, this inquiry-based process. These are the skills that ultimately you want to have. These are the students we want to create. This is a way to make the world a better place. In order to trust the creative process, we first have to have a framework in which all this can happen. So as it mentions up here of getting started, picking an engaging topic. And we've seen this both in the PBL works and the high quality project-based learning. It all begins with picking that main idea, the question that drives it, the research problem behind the project itself. So how do we find out what that is? You start with what's called a driving or guiding question. Driving questions guide instruction and learning activities. They elicit a desire to learn. Guiding questions provide the foundation to scaffold concepts or principles, or practices. This is the way that you can take it back into your particular discipline, into your particular learning objectives. Driving questions are meaningfully anchored in real-world situations in order to meet some of those essential qualities of project-based learning. And a good driving question illuminates an important problem. Easiest way to think about what a good driving question is, Google cannot answer that question. So, think about it this way. If the driving questions are feasible so that students can actually answer them, they can perform investigations that are either not too hard or not too easy. They have to be worthwhile. They have to be relevant. Ideally, they're contextualized in ways that make it authentic or non-trivial and important. They're meaningful in that they're interesting and exciting. And it's always important to mention that, of course, they need to be ethical, or it shouldn't ever do harm to people or organisms or the environment. I think that if you've been around teaching enough, you know what a good driving question is, because you know that it's not just something that a person could look up. You know that these are the things that your research is probably involved with. These are the things that ideally you'd like to see students really learn about. So what are they? Sometimes it's easy to know what they're not. So I'm going to give you a yes and no example. So an example of a bad guiding question would be, who were the first settlers in our city? Well, we could look that up. But instead, what if you switch that to, what were the most important causes of our city's growth? There's still research involved, but now it's a research in which they're inquiring and really starting to study this in new ways, new resources, new conclusions. Not everyone's going to get the right answer. Same answer, I mean. Why do airplanes fly? Instead, how do we design a lighter and more sustainable airplane wing? What's a healthy caloric range for kids? Could easily be switched to how do we convince teenagers to be healthy eaters? What was the Selma to Montgomery March? How do people show resiliency in the face of challenges? I want you to look at those guiding questions. Let's perform that backwards design again. What artifacts, what evidence do you think would be able to be a way, if we envision the final days of that particular project, what sort of evidence in your field do you think would be appropriate if you ask questions about the city's growth, history, science of airplanes, healthy habits of eaters, resiliency and social justice issues? So as you're developing your work, this is where it's going to come back to you. Consider the purpose of your course, the one that you're envisioning. Earlier, I'd asked you to think about the evidence and the artifact. Now I'm asking you to think about the guiding question. What types of questions might guide the student activities? Are these the great problems? Is it related to food and water? Are they more particular problems related to the exact topic of your course? What questions might lead to the final artifact that you'd envisioned earlier? Your guiding question happens at the beginning of the course. It's how you design your course. But to be crystal clear about this, guiding questions have to happen throughout the course. You can adjust your teaching to meet the students where they are by asking better questions, more refined questions, to help guide their continued work. For our next meeting in October, just a couple things to talk through. If you were to model some guiding discovery questions, think about the larger disciplinary context. Are there other perspectives or expertise that would be beneficial? In architecture, perhaps it's construction engineering, or it's landscape architecture. What are the 2 to 3 central learning outcomes for the course? This comes with all course planning, of course. But remember, in the PBL works, these learning objectives were the hub in which everything else spiraled around. Based on those learning outcomes, what type of question or problem is typically linked to these types of disciplinary explorations outside of academia? What happens in practice? And when we think about what sort of question is linked to those, is there a way you can grab onto similar questions and immediately make that the authentic part of your learning outcomes? Envision what you think an ideal outcome for these efforts might be. What would this final presentation look like? Would they need to collaborate? If you work backwards from this goal, how much time do you imagine will be needed, or how many phases of the work? We'll show you good strategies for how to actually plan this out in October. Imagine you're a student taking this course. Knowing what you know now as an expert and an instructor, what skills or knowledge do you wish that you'd have been taught to be able to handle this topic? Hard, soft skills? And finally, I'm a big believer in thinking about the greatest potential threats that concern you about this. Am I going to run out of time? Do I actually have time to teach teamwork? Will I be able to assess in a regular manner? Do I have enough students who are able to be engaged in this particular process? Thinking about those threats is going to allow you to model some either guiding questions or start to lay out a framework for your course. Thanks so much for your time today. I'm looking forward to our conversations in October, where we're going to talk more about setting up these courses, some of the tactics included in these courses, and basically how to scaffold this learning between what we looked at today, which was the backwards design and the guiding questions.